Welcome back to Coach Quant. Today we're going to be looking at a problem on colors, permutations of colors on the faces of a cube. So let's start off by reading the question. Imagine painting the six faces of a cube, each in a unique color from the possibilities red, blue, green, yellow, purple, and pink. Determine the likelihood that the red, green, and blue faces all meet at a single vertex of the cube. So the cube has six unique colors, so none of them repeat. We want to find the likelihood that we get red, green, and blue at one vertex. So, as in almost most probability questions, we want to sort of figure out what's the sample space of the scenario that we're interested in, of getting red, green, and blue at one vertex, and what's the sample space of all the possible combinations of colors on the cube. Um, And so, since we're choosing things without replacement, right? When we paint a cube, we are assigning a color, a unique color to each of the six faces of the cube. So the possibilities of choosing six colors uh, from six possible colors, is six factorial, right? So there are six possible. I mean, where do I put the first color? There's six possibilities. The second color, there's one less possibilities, right? There's five possibilities. The next color, there's only four spots remaining, so four. And so the answer for the total number of possible places is six factorial. And we now want to look at the scenario that's in question of getting red, green, and blue at one single vertex of the cube. So let's just pick one vertex, okay, to simplify our math here. Let's just choose one vertex. So one vertex looks like this, right? And we need to put red, green, and blue around this vertex. How many possible ways there are of assigning red, green, and blue in this vertex? Well, there's three possible places to put three possible colors. So we could put red can go in any one of these three spots, right? Let's just put it here. So there's three. And then we can put green in either one of these two spots. So there's two spots. And then blue, there's only one spot remaining for blue. So we just put that there. And so the total probability is 3 factorial. Um, so which is just 6. Um, but now we also need to consider the orientation of the colors of the three other faces once we've oriented green, red, and blue. So those will also need to be put in three spots. So the other faces, there's for those, there's 3 factorial possibilities, right? It's the same scenario. We just have to put now um, the yellow, purple, and pink in the other three spots. So which gives another 3 factorial possibilities. So if we choose one vertex on the entire cube, the number of the number of possible uh, orientations of our colors on the sides of the cube, such that red, green, and blue meet at that vertex, is equal to 6 times 6. Um, and so now we need to consider the possibility of them meeting not just at a specific vertex in the cube, but on all vertices. And so this situation is equivalent on all vertices. And there's 8 vertices total, right? 8 vertices total on the cube. And so the probability of this scenario, right? We'll call this scenario S, of red, green, and blue meeting at any of the vertices on the cube is just 8 times this, right? It's 8 times this. And so to find the probability of this situation happening, we have to divide by the total number of possible orientations of colors on the cube period, which is 6 factorial, as we found above. And so we can easily simplify this, right? There's a 6, there's a 6, 6, 3 times 2, 8, 1. So this is just equal to 2/5. So our final answer is 2/5. Um, we have many more problems like these on our website, coachquant.com. I've left a link in the description, so you can go check out all of our questions, solutions, and hints. If you're preparing for quant interviews, you can go check out your firm on our website, and we have a list of many, many quant questions that have been asked by your firm in the past. Just go to our website in the description, coachquant.com, check it out. It's completely free. I really, really recommend you check it out.